So now, if you guys go to your second page of your worksheet, I have some problems. So now the first one we'll go over together, and the second two I'll have you guys do individually. So here, let me erase this. We'll go over the first one together. So as you can see, we're having sodium and chlorine bind together. So we're having Na and Cl. So kind of going over the different steps, how many valence electrons does sodium have, Na? Yes, Josh? One. Right, since it's in the first column, that will have one electron. And how many does chlorine have? Which column is that one in? Yeah, Tom?
It's 7.
7, right, because it's in the 7th column. So as you can draw in, you guys can follow along on your sheet. So 1, 2, 3, 4, 5, 6, 7. So you guys following so far? So thumbs up if you're following. Thumbs down if you're not. All right, great. So how many electrons does chlorine need to reach the octet rule? Do you guys remember the equation we came up with? So you guys want to say it out together? 8 minus 7 equals 1. Exactly. So 8 minus 7 equals 1. So now, if you guys are looking at your G charts, does it involve metals or non-metals?
Both.
Right. So what does that mean?
Means it's ionic.
Right. So as you can see, you guys can circle metals and non-metals. So ionic. So what does that mean about the electrons? Are they being shared or transferred? Yep, Tony?
They get transferred.
Right, exactly. So as you can kind of follow on the list, if it involves the metals, it's ionic, and then electrons are being transferred. So what does that mean? So what should I draw on the board then? What's being transferred?
1 electron.
From chlorine, or from the metal, or from the non-metal?
The metal.
From the metal. So it's going to be transferred from here to there. So we can erase that. So then that means that has 8 on its outer, and then 8 electrons in the outer shell, and then this has 8 on the inner shell. So they're both completed the octet rule. And now, how do I draw? How do I name this using the charges on each electron? Which one's giving up electron? Which one is taking it in?
Sodium becomes positive.
Right. Positive what?
Positive 1.
Right. So they give up 1 electron. And then what happens to chlorine? Josh again?
It becomes minus.
Right, exactly. Because it took on 1 more negative electron, it became more negative. And like we said, since opposites attract, there's a bond going in between these two to come together. Great, so do you think you guys feel comfortable doing the next 2 by yourself? Great, so I'll kind of give you guys a few minutes to do that by yourself. I'll walk around and see if you have any questions. And then I'll go over what the homework is for the rest of the day. And that should be our lesson for today. So you guys remember the formula? 8 minus
6.
right.
I have a question.
Yeah.
But it's not. Can 2 metals bond together?
That can. We're going to go over that tomorrow. But today we're kind of looking at these 2.
Okay.
How's about you guys? Yeah.
Can 2 electrons move over, or can only 1?
No, 2 can as well if you want.
Okay.
So you guys both done with the first one?
Mm-hmm.
Any questions on my first one?
I don't think so.
So raise your hand if you got covalent bonds. Ionic. Great, you guys all got it right. And like Brenna asked, did magnesium give up 1 or 2 electrons? Or more? 2, yes, it gave up all of their electrons. Since it's a metal, it wants to get rid of them. Whereas the non-metal, oxygen, wants to take them in. So oxygen was greedy and took both of them for magnesium. But they're both fine because they both complete the octet rule. So now you guys can go on to the third one, and we'll be done for today. Don't worry, you can erase it, just pencil. Now this one a little bit trickier, but I think you guys should be able to get it. Yeah, Brenna?
I'm confused because there's 2 H's.
Right. So like I said earlier, chemical bonds include 2 or more different atoms. And so with water, or H2O, there are 3 different atoms. And so there's going to be bonding from all 3 atoms. And so did you guys find it was ionic or covalent?
Covalent.
Covalent. So electrons are being shared. And so the 3 of them are just being shared all together.
Could you write it up on the board?
Yeah, sure. Well, why don't I have one of you guys? So, Tony or Josh, which one do you guys, either you feel confident about your answers for number 3? Okay. Great. So, you want to come up and draw number 3? And Brenna, do you want to do number 2 on the board as well? So you guys can do it right where you sit here at the table.
So you just want me to write the picture?
Yeah, so right the picture. And then,
I'm confused because doesn't hydrogen need to have 8 in its outer shell?
no, remember that's the special one that you went over.
Oh, right, hydrogen
Only-
needs 2.
Right. But good question. Great, good job, Josh. Great, good job, Brenna. Yes. So, Tony, is this what you got as well?
Mm-hmm.
Great. Yeah, so as Josh put up on here, Brenna, since this is a covalent bond, since these are all involving nonmetals, including the hydrogen exception, these electrons are being shared among all of these atoms. And so, as you can see, there's actually a vent shape to it, but these are all being shared like this.
Okay.
And then, as you can go over with number 2, like number 1, this also was an ionic bond, and so both of these electrons are being transferred to oxygen. And since there's 2 involved, there's +2 and -2, whereas before we had just negative and +1. Great. So, is any final questions? Perfect. So tomorrow we're going on looking at different types of bonds, but this is the lesson for ionic and covalent bonds. Thank you guys all. Enjoy your day.